Cool. So thanks for coming back to week 5, guys. Today we are going to speak about testing smart contracts. Let me share my screen. Cool. So just as a bit of a primer, we can look at how what makes testing so critical when it comes to smart contracts versus normal Web 2 testing, where we're just testing a front end, back end kind of thing. So in like Web 2 development, when we deploy to our server, if there's a bug that exists, right, we can then find the bug and then fix the code and redeploy, right? There might be some downtime on your website. Users might get a bit frustrated, but funds are safe, data is safe, and there's no real permanent damage. Just some downtime on your application. But when it comes to smart contracts are, when you deploy them, they cannot be changed. They are immutable. So if you have a bug in your smart contract, when you deploy it, that bug is there forever. So if someone interacts with it, someone finds this bug, all your funds can be lost. And this is permanent. There's no way to get these funds back. There are mitigating ways to mitigate this with upgradable contracts, but that is a topic of discussion for another module. For now, we'll just treat all our smart contracts as immutable because this is really the way you should think about your smart contracts when you develop them. You don't want to develop them with mistakes in mind. You need them to be perfect the first time. So this is where testing comes in. And you want to test every single line and every single branch of your contract. So the testing philosophy in Web3 is if it's not tested, it's broken, right? That means we have to test every single thing, every single interaction in our smart contract, everything. So once again, here we can see additional software, we deploy, we fix a bug, we can redeploy. In smart contracts, we deploy, if a bug exists, it's there forever, right? Testing is not optional. It's the insurance policy against catastrophic loss of funds. From last week, we've got just initializing Foundry and starting a Foundry project. This is what we're going to do today. So today we are going to test a smart contract. We're going to write some tests for a smart contract that I have. It's our SimpleVault contract or Simple Bank that we did last week. We touched a bit on tests last week, but we didn't really dive too deeply. So this week, I think we can maybe write and see how much coverage we can get for this smart contract. So here we've got our SimpleVault contract, right? Do I need to make it a bit bigger on screen or is it fine? Can you guys see?
It's good, eh?
Is that better? Or that? Maybe I'll stick with this.
Other one, if you can.
The other one, okay, this one.
Yeah.
Cool. So here we've got our SimpleVault contract. It's got a few storage variables over here. It's got a few events. It's got one modifier. It's got a constructor function. There's two public functions, deposit and withdraw, and one admin function that allows an owner of the contract to set the minimum deposit amount, right? And there's an internal function that's just called in the modifier. So first things first, we're going to build our contract. We do forge build, compile. Everything compiles successfully. Don't worry about these compiler warnings. We'll get rid of them sooner. And then to check our coverage, we can just do forge coverage. Right? It'll run everything, and there it tells you how much of your contracts are tested. So we are just testing the SimpleVault contract. That's all we're interested in. Here we can see our lines of code, 22 lines, 0 tested. Statements, 17 statements, 0% tested. 10 branches, all 0% tested. and 6 functions. Nothing's tested so far. So today we are going to see how high we can get our test coverage for the SimpleVault contract. Can we get to 100% coverage? Okay. So in order to start, we need a test contract. So in your test folder, you create a simplevault.t.sol file, and the .t.sol suffix just means that it's a test file. We import this testing contract from Foundry's standard testing library that comes built in with Foundry whenever you install it. And this just gives you access to various assertions and various basic ways to manipulate the blockchain in your tests. And we also import the contract that we want to test, the SimpleVault contract, right? Then we create a test contract. It's called SimpleVault test, and we inherit this testing contract from Foundry, right? Okay. So the first thing we want to do when we test our contract is instantiate some storage variables, right? So first things first, we're going to get an instance of our SimpleVault contract. So as the AI says, SimpleVault public, I'll call it SimpleVault. Right. Then we need some actors. In here, we can use our very first function that we inherit from this test contract, and that's something called VM. So we can do address public owner. Oops. It's equal to VM dot addr1. Right, and that just creates an address and sets it as the owner variable. Then we need 2 people to actually interact with it. Yes.
So can I ask about the access? What's our access actually?
Actors are just going to be users that you are going to instantiate to use your smart contract. So it can be anyone. It's just random addresses that we are going to create to interact with our contract. So they simulate actual users in the real world. So we call our first one Alice. That's standard. We can go make.
Oh, so you just making up your address?
100%.
Oh, okay.
These are just they're just random addresses. You don't have to worry about what they are, but just know that they are different. Just like your EOA or your MetaMask address, your public key is unique and different for each wallet. This one will be unique and different for each actor.
Okay, thank you, sir.
Sure. Okay. And now we're gonna have to write one more thing, and that would be our setup function. Your setup function is pretty much the most important function in your tests because it runs at the beginning of each test and to make sure that each test runs on a clean slate. So before you run each test, it will set up all the things that you write in here. And then at the end of each test, it will break it down again so that you have a fresh instance to run your next test against. This just makes sure that tests can be run in any order, and one test does not depend on another test results. We need to keep our tests as isolated as possible when we're testing unit tests. Because these just test individual lines and state changes in your contract. So we write a function called setup, and this is just basic. It's a public function, and it doesn't return anything. So in it, we are going to first deploy our SimpleVault contract. And our SimpleVault contract needs an owner. The owner is just whoever is the person that deploys it. And here we can see in our constructor, it sets the owner to message.sender, and this is the person that calls, that deploys this contract. So the way we do that is that in Foundry tests, if you do not instantiate a caller, it will just assume that this contract itself is the caller. So basically, if I do SimpleVault is equal to new SimpleVault Ether, right? The owner of this contract would be what's called the owner would equal what's called address this, right? That means this contract, this SimpleVault contract, SimpleVault test contract, that would be the caller of this function. But if we want one of our actors to call it, in this case, the owner, we use what's called a prank method. So we can do vm.prank and pass in the owner variable. And then all this is for the next call, make sure that the caller of the function is this address and not the contract address. So then the caller of this function will be the owner address. So we've deployed our contract in our setup, and now we want to give our actors some money to deposit and withdraw. So as the comment says there, fund Alice and Bob with some ether. This is pretty cool. You can also do vm dot deal, and you can tell how much to deal. Let's say 10. Let's say 1 ether. And we can give the same to Bob. And then we can write our first assertion that assert equal. And the way to check the balance of an address is just the name of the address dot balance. And this just says our first assertion is an assert function. It asserts equality. So it will assert that whatever is on the left-hand side of this comma is equal to what's on the right-hand side of this comma. So this is just going to say we're dealing Alice and Bob 1 ether to spend, and now we are asserting that this deal happened, and Alice now has 1 ether and Bob has 1 ether. Okay. Now our contract is set up. Basically, our test contract is set up. We can try and compile again. See if we did everything right. Hold B. Shortcut. Looks happy. Compiled successfully. Okay, time to write our first test. So initially, before we actually start testing any of these functions in our contract, you first have to test that your contract state is as you expect after deployment. So if we have passed this minimum deposit amount in our constructor during deployment, we expect that the storage variable here should be equal to whatever we passed over here because it was set in the constructor. That's your initial state. You need to check the owner of the contract, the owner variable of the contract is equal to the caller or the deployer of this contract. And we need to check that this event was emitted. that is your initial state of your contract right at the beginning, before anyone ever interacts with it. So our first test would be function test, because all tests need to start with a keyword test. Foundry actually looks for this keyword to run any tests. And if your test does not start with the word test, it will get overlooked and it won't get run. So we're going to say test simple test initial state is as expected. Okay. All tests are public functions. So we just mark it as public and we can close our brackets. Okay. Testing names are also very important. What you call your test. You don't want to write a function that sounds like function test one. That is bad practice because it doesn't say anything about what you're testing. So if I were to come along as a developer who's never seen this code base before, and I'm reading through your tests to get an understanding, I look at this function and this should tell me, okay, this is what I should expect my contract to look like when it's deployed. This function tells me nothing in the test name. It just says test one. I don't know what it's doing. So be as descriptive as possible when writing your test names. Okay, so what do we expect our state to be initially? We expect our minimum deposit amount to be the amount that we passed in our constructor, in this case, 0.1 Ether. And to make this even more explicit, we could do something like uint 256 public constant. A constant variable just means it can't be changed. When deposit equal to 0.1 Ether. And Ether just means you're adding 18 zeros on the end of this number, because on Ethereum, all numbers have 18 decimals, and this is the shorthand for that. So now we can change that magic number to this. And following on with that standard, we can then do public constant initial balance is 1 Ether, and then we can use that variable now with our tests. This is better practice than putting your magic numbers straight in, as it's more descriptive. If someone reads your tests, they can just easily see what's going on, as well as if you need to change anything, you just change it in one place instead of having to change it in 5 or 6 or 100 places. Okay, so the first thing that we need to check, who deployed this? Is the owner of the SimpleVault is this owner equal to the person who called the function and deployed the contract? So we say assert equal, all right, we call our contract instance SimpleVault dot owner, the owner function, and we assert that it is equal to the owner that we set up over here. Okay. This owner function, because this is a public variable, like I said a few modules ago, if you declare a variable as public, Foundry or Ethereum, it generates a getter function for it automatically. So this will automatically turn into a function called owner that will return this variable. So now we can check, does the owner of the SimpleVault equal this owner address? So let's run this test. Copy the name. Say forward test dash dash match test and paste it in. Run it, compiles, and it passes. Okay, great. There you can see test passed, 1 test passed, 0 failed, 0 skipped. So now we know that's correct. The next thing to assert is that the min deposit amount is the same as what we passed in, min deposit amount. So we say assert equal, same thing, SimpleVault dot min is equal to what we set here as the min deposit amount. Run our test again, and it passes once more. So far, our initial state is as expected. We can test that the state of this balances mapping is as expected. So no one should have deposited anything into the contract. So the balances of our users that we have set up should be 0. So the balance of Alice in this contract should be 0, and the balance of Bob should be 0. So we can assert that SimpleVault of Alice, who is our user, is equal to 0. And we can do the same thing for Bob. Let's run our test again. And it passes. So we know that the contract state is is as we expected it to be when we deploy. Everything is in a beginning position as we expected. Now we get to check that this event gets emitted by this contract upon deployment. Like when the constructor runs, this event should be emitted. So we want to say a new test, function test, construct show emits event. Public once again. And that's the way we do this. We say we expect, we use a cheat code called vm.expectEmit. Right. Expects an event to be emitted. Then is it indexed? So you can index 4 event parameters. They are not indexed, or are they? Don't think so. No, they are not indexed over here, as you can see. So we say false. And the last one is there data on the event? Yes, there is. It's always true. We need to tell the contract what the event is we're listening for. So we just copy that and paste it at the top. And then we say emit. This is what we're looking for. We're listening for the SimpleVault initialized event with the deposit amount and the owner address. Right? Now we're going to deploy a new contract and see that this event is emitted when it's deployed. So the way we do that, we do it again, vm.prank owner, and we call new and the money deposit amount. Okay, so now this event should be emitted when this contract call is made by the owner. Let's try it. We can run both tests. We just do forward test. And here you can see we have two passing tests: constructor emits event and initial state as expected. If maybe we passed in something else here, like it was maybe 2 that we expected, and we were still looking for a money deposit amount, this test would not fail. And here you can see Foundry gives you a nice message about why your test failed. It said expected an emit, but no logs were emitted. You might have mismatched your events, or not enough events were emitted. So that's because the arguments here are incorrect. They don't match what was supposed to be emitted in the event. Okay, so that's our initial state. When deployed, the min deposit amount set, the owner set that event is emitted. Let's see if we have increased our coverage. So yes, we have. Cool. We now have 4 lines of code covered, 18%. We have 3 statements covered, and we have 16% of our functions covered. That's just one. That's the constructor. So we're making progress. So before we jump in to these functions, we're going to test this admin function over here, purely because it has a bit of access control enforced by this only modifier. And this modifier just says that only the owner who was set in the constructor can call this function and update the minimum deposit amount. So the way we test that, we would say, first of all, terminal, let's make a nice header for what we're testing. And I would say init tests is, I always like my tests and my contracts to be nice and clean and commented, so that whoever reads it knows exactly what's going on. It can be a bit hard to read if you have like 100 tests in one test contract. So now do headers add tests. Let's paste that in. And then, as the AI suggesting, that should be called test owner and update when the budget amount. It's public as usual. So now, before this test runs, the setup function will run. Give us a new contract instance with a clean state, so we can test what is this min deposit amount initially. So upon deployment, we set this as 0.1 ether. So now we can check that it is. So we can say assert equal that the SimpleVault min deposit amount is equal to that, right? So that's our first state check. Then we say pm.rank the owner address. So this means the next call to a function is going to come from the owner address. And then we say update it to 0.2 ether. In fact, we can say uint 256 new min deposit amount is 0.2 ether, sticking away from magic numbers. And we can assert that the new min deposit amount is now equal to this 0.2 ether and is no longer this. So if we run our test, forge test or forge t -mp, that's shorthand for match test. Copy our test name. paste in, and let's add some verbosity. Tell us about our test, and there we go. Test passes, then our min deposit amount is now updated. So we know that this function correctly updates the state of the contract. Now we have to test that it denies any other user access to calling this function. So this is what we call a negative test. Specific function test, non-owner cannot set amount. Okay. So we're going to say our new deposit amount is right. And our call is going to come from Alice this time. So we go vm.prank Alice, right? And we're going to do another cheat code from the VM library, and that's called expect revert. So vm.expect revert, and we need to copy whatever message we are expecting to be reverted with. So this, in this case, only the owner can call this function. So that's the error message we are expecting when a non-owner calls this function, and then we simply just call it, and this test should pass because the revert is as expected. So again, copy the name of it. Forward T /T. And there we can see our test passes once again. If we were to set this caller as Alice, we would see that it would revert with our error message, but the test would fail because that is not what we were testing for. See, test failed, and it failed with the error message, only owner can call this function, and it failed because Alice was calling it when she was not allowed to. If you are kind of stuck and you cannot figure out what is happening in your test or why it is failing, you can increase the verbosity of your test, just give you some more information. So these two V's increase your verbosity. So VV will print your logs, VVV will give you a test trace stack, and VVV will give you all the call logs and stacks and events for this test. So if I run into that, you can see the traces happening. You can see what function calls were happening. You can see our setup function was called with a prank from this address. It returned a new SimpleVault at this address. You can see the events being emitted. And in this way, you can debug your test and then figure out what is going wrong or where it's going wrong. So let's set this back to owner. And once again, we've tested this modifier, we've tested the state update. Now we need to test the event. Simple, just like the last one. Copy this. You can paste it in and you can say test. All right, set main deposit amount. Okay, new deposit amount. Once again, we need to copy the event into our test contract. And update the name. And make sure we're calling the function. So once again, we are expecting an event to be emitted. We are emitting this event over here, and that's the one that's being expected to be emitted. When we call this function, set minimum deposit amount, we will wait and listen for this event, and this text will pass if the event and its correct arguments are emitted. Forge T, cool. So we have quite a few passing tests. Let's do forge test. So far, 5 passing tests. And our coverage is increased to 20% of our lines of code have been covered. Not bad. 2 branches, that's 14%. And 4 functions have been covered so far. That's 22% of the functions in your contract. So this only owner modifier, we've tested this modifier inside this admin function. That's called access control. This only owner modifier calls this internal function, which is specified down here. And in that way, we are actually testing that this function works. Because this function is internal, there's no way to call it in this SimpleVault test contract, because only other functions inside this SimpleVault contract can see this function, because it's internal to this contract. But it is exposed via the modifier over here. So by testing this modifier, we are then testing this function. And that's how you test. That's one way of testing internal functions, is you test either the modifier or the public wrapper that wraps around an internal function. Okay, so now we've tested this function, we've tested this function, we've tested our constructor, and we've tested that our state variables are as expected. So now we can do our public functions, right? This one over here. Can maybe someone recommend a test for us to write for this deposit function? Like, what would be our first test we would want to write? Anyone? You guys still there? Did my connection drop or something? You were live. Okay, you are still alive. Okay. So the first thing we want to test in a deposit function is that a user can actually deposit funds, right? And when they deposit, their balances are updated. That's the very first thing. That's the first practical functionality of a deposit function that we want to test. We want to test this line. Does it increase the balance of message.sender? So let's make a new header. Let's put public. And we paste it on it. And now we say function test deposit updates balance. Right? Public as usual. So first things first, we assert that Alice has a 0 balance in the contract in the beginning. Then we say pm.frank. We want Alice to be the caller of this function. And we say SimpleVault dot deposit. Call the deposit function. We pass in a value which is ether of 0.5 ether, and there's no arguments in the parameters. So this syntax here with the curly braces, this is how you would send Ethereum to a contract or to another address. Because it's not because Ethereum itself is not a smart contract, the syntax for sending and receiving it is a little bit different just because it's a native token. So that would be how you would do that. And then you would assert that the balances mapping for Alice has increased to what she deposited. So let's run this test. And yes, we can see balance has successfully updated. Good. So we've tested that. Now we need to test that you cannot deposit less than what the minimum deposit amount is. So we write a test. Test cannot deposit less than minimum deposit amount. Public. And we say Alice is going to make the call again. And we're going to expect the revert. Expect revert. And what was our error that we expected? Deposit amount too low. And then we try and deposit a really small amount. We could even do deposit so this makes sure that we are depositing less than the minimum deposit amount. Let's check if this reverts as expected. And it does indeed. So we know that our function required checks are working as expected. The last thing for this function is that we need to check that it emits a deposit event. So once again, copy that. Add it to our test contract. And we can copy another event test. Paste it at the bottom. Test deposit emits event. Deposit amount is 0.5 ether. We expect a event to be emitted. We expect the deposit event to be emitted with Alice as the message.sender and the deposit amount. And then we call the function from Alice. and we say deposit amount. Once again, we run it. Great, and it passes. So now we can see. Now I have 8 passing tests for this vault. We can once again do forge coverage. And we can see that our testing coverage has increased to 27%, roughly. That's not bad. But we've still got a few more. Actually, we've still got one more function to test, and that's this withdraw function. But I see we are running out of time. So before we go, do you guys have any questions so far about this? Yes.
So can you please send this vault? Please give us the link so we can do it ourselves and see if it works.
Oh, 100%. So I will leave this withdraw function untested. You guys can see if you can write some tests for it. I'm gonna push this to the repository that you guys have been working with, the ETH-Course repository, and then you can just pull from the testing branch, and you can write these tests. You can run them, you can compile them, you can see how it goes. And then see how far you can get the total test coverage up for the SimpleVault. So you can see we've got 68% covered there, 44 out of 10 branches, 80% of coverage of functions covered. So it is pretty good. But let's see if we can get this SimpleVault contract up here up to 100%.
So
Yeah.
So are you gonna find the link on WhatsApp via
Yeah, I'll put it on the blockchain support group. I will put it in an email after this, and I will also put it in the chat now.
Yes, thank you. So we really appreciate it.
Not a problem. So I'm committing my changes. I'm going to say simple tests. And okay. So in our GitHub repo, we can go to here. We see. Oops, just refresh. Okay, you can see I'm clicking on this little button here in our repo that changes our branches. Otherwise, you can click on that says branches, and you can click on the testing branch. And in there will be the smart contracts for SimpleVault, as well as the others we've done. And there's the tests that I've written all set up for you. And you guys can just go ahead, clone this, and start writing some tests. So let me just paste it in here. Testing branch. Oh, here is the link.
Pasted it. You don't have to stress.
It is? Oh, thank you.
Pleasure.
Awesome. Sweet. So yeah, that's pretty much unit testing in a nutshell. Next week we're going to get into a little bit more advanced testing methodologies. We're going to cover a bit of fuzz testing, which is basically testing this withdraw function or this deposit function, but not just with one input like 0.5 Ether. We would test this deposit function with many random inputs. That's called fuzzing. So that's good for catching edge cases, testing boundary values, testing like max values, min values, that kind of thing. It's cool because it's built into Foundry, and Foundry will run probably thousands of input parameters against your contract and see if it can break it. Then we're going to look at invariant tests a little bit. We won't write any invariant tests, but I'll just let you know what they are. Invariant tests is basically just testing the state. It's called stateful testing. So basically, where fuzz testing, it starts with a clean slate after each test. Invariant testing doesn't. So invariant testing keeps the state of your contract between function calls and tests. And this is just to simulate a live environment when it comes to tests, and to check that certain things in your smart contract that should never be broken, or rules that should never be broken are never broken. So like numbers should never go below 0, or certain numbers should never go above a certain value, that kind of thing. Certain formulas should never be broken. Invariant testing is good for checking those kind of things. And then we're going to cover a little bit of integration testing, which is just using your deploy script inside your tests to make sure that when you deploy your contract, it's as expected, and you're not separating deployment from your actual testing. Because if you do, you could be thinking that your tests are passing and you're all happy, but then you go and run your deploy script and it deploys something completely different, and you are then deep in trouble. And then finally, we're going to look at fork testing. And fork testing is just testing your contract against a fork of a live network. So Foundry allows you to fork Ethereum mainnet or Ethereum testnets, and you fork the live state of the network as is, like currently, and then you can test your contracts against this live network. This is very useful for pre-deployment testing, so you know your contracts are going to work with contracts that are out there in the wild, being run live on the network. So once you have all these tests written down and implemented in your repo, then only can you consider your contract to be deployable or ready for deployment. So yeah, that'll be next week. Thanks for coming again, guys. I do appreciate it. If you have any questions, feel free to message on the group or send an email or anything like that. We will try and answer it as quickly as possible.
Awesome. Thanks, Miles. Thanks for joining, guys. Any questions? Nope. Okay, cool, guys. I'm going to say good night. And yeah, thanks a lot for joining. And chat to you guys in the chat or next week on call.
Yes, sir. Cool. Thanks, guys.
Thank you, sir.
Cheers.
Okay. Bye.